So this is the 2015 Leaving Cert Higher Level Paper 1 and we're looking at question number 1. Mary threw a ball onto level ground from a height of 2 meters. Each time the ball hit the ground it bounced back up to 3/4 of the height of the previous bounce as shown. So here we have the diagram showing the bouncing ball. Part A says complete the table below to show the maximum height in fraction form reached by the ball on each of the first 4 bounces. Okay, now a key word there in the question is maximum height, because in the question, in the information in the question, it tells us that each time the ball hit the ground it bounced back up to 3/4 of the height of the previous bounce. So if we're completing this table, we can see that the first part is filled in. It's dropped from a height of 2 meters. That's the vertical height that it begins with. And the first bounce, the height that it reaches is this height here, which will be 3/4 of 2/1, or 2. So 3/4 of 2 is 3/2. You can do this on your calculator, and remember they want it in fraction form. So each time we move along now, for each bounce we're going to find 3/4 of the previous value and leave our answer in fraction form. So 3/4 of 3/2 gives us 9/8. 3/4 of 9/8 gives us 27/32. And 3/4 of 27/32 gives us 81/128. And again, you can find all these values on your calculator. Okay, so that's part A. Part B says find in meters the total vertical distance up and down the ball had travelled when it hit the ground for the 5th time. Give your answer in fraction form. Okay, so again, it's the total vertical distance, which is important, up and down, when it hit the ground for the 5th time. So if we go back, this is where it hits the ground: 1st, 2nd, 3rd, 4th, and 5th. So we're looking for the vertical distance. Now, remember, this is not the distance of these parabolic curves here. That would be the total distance it travels. We're only looking for the vertical distance it travels, up and down. So the first vertical distance it travels is 2 meters down from the first throw. And then once it bounces, it travels. Once it bounces, it travels back up to this height and back down. And on the second bounce, the vertical distance is up to the height of this and back down. And similarly here on the third bounce, to this height and back down. And finally in the 4th bounce, before it hits the ground for the 5th time, is here, up and back down. So it's the total of all these distances here that I've marked with these blue arrows. So it's going to be the 2 meters plus twice each of these distances here in the table. So that's how we're going to find the total distance, the total vertical distance. So that's going to be 2 plus twice all the other distances, which were from the table 3/2, 9/8, 27/32, and finally 81/128. So remember, this first 2 is for the first vertical distance from the throw down to the ground, and then this 2 here is the doubling of each vertical height for the bounce to account for the up and down vertical distance. So we can put all of this here into our calculator, and it does say to give your answer in fraction form. So fraction form would be 653 over 64. So that's fraction form. That will get you full marks. If you do want to change that to mixed numbers, you can. So that would be 10 and 13 over 64. Both answers will get you full marks. And don't forget your units. That will be in meters because it's vertical distance. Okay, part C. If the ball were to continue to bounce indefinitely, find in meters the total vertical distance it would travel. Okay, so if the ball were to bounce indefinitely, that's another way of saying it bounces an infinite number of times. It keeps bouncing. And remember, if it bounces to 3/4 of its previous height, that means it never stops bouncing. So we've defined this total vertical distance that it would travel. Now, because it's bouncing indefinitely, we can treat part of this answer here as a geometric sequence, and we can then, if we do that, we can then use the sum to infinity from our tables book to find out that part of the answer. So we've got 2, which was the initial height again, plus twice. This time we've got the 3/2, the 9/8, the 27/32, 81/128. But again, remember that this is going to keep bouncing now indefinitely, so it's plus ... and on it goes. So if we treat this part here that I'm highlighting as a geometric sequence, well, then we can find the sum to infinity of that geometric sequence. So if that's a geometric sequence, the formula for the sum to infinity of a geometric sequence is here in the right hand corner. I've taken this from the tables book. So this is a over 1 minus or, where the modulus of or is less than 1. Now or represents the common ratio, and the common ratio for this sequence, if you remember, was 3/4, because that's what we're multiplying as we go along. So or is 3/4, and because that's a fraction that's less than 1, or a number that's less than 1, we're allowed to use this formula for the sum to infinity. Remember that a represents the first term of the sequence, which in our case would be 3/2. So now that I've established a and or, I can substitute these into my formula. So that's going to give me 2 plus 2 times a, which is 3/2, all over 1 minus or, which will be 1 minus 3/4. So again, just to be clear, I'm going to highlight these values here. The a is this here, and I've substituted it in here. And the or value is the 3/4, the common ratio, which I've substituted in here. And remembering that it's only this part of the brackets, in the brackets here, that is being treated as a geometric sequence. So now that all that's remaining to do now is to substitute all of this into my calculator, and I get a final answer of 14 meters. Remembering it's meters because it's distance again. So that's the end of part C and the end of question 1.